Greetings YouTubers, and welcome back to part 2 of hacking this Xbox power supply. Quick recap from part 1. What have we learned? Number 1, just because it's sitting on the shelf for 10 years doesn't mean that it works or that you ever should have kept it in the first place. Number 2, sometimes pins just disappear. Number 3, ammonium chloride makes really bad and cheap soldering iron tips usable. But it's cheaper to buy a pound from a chemical supply than 2 of these things. I have had this one since 1999, so I don't actually know if I'll live long enough to make that worthwhile. Number 4, I clearly haven't learned to edit videos because none of the text that I put on the screen explaining things ever showed up on the final video, and I didn't notice. Obviously, if I'm just pointing to things that are not here, I still haven't learned. Number 5, this continuity tester is a terrible design, and it resonates with some coils, but not all coils. Number 6. The 5-volt rail needs to have a load to work properly to make the 12-volt rail work. 27 ohms seems to be about the minimum. And what haven't we learned? Anything that we were actually trying to figure out in the first video. Like, how do we modify the voltages? So, let's get to that. I thought I killed this thing yesterday, but now it does seem to work. I just tested it. I guess it was the boost converter that died. We'll look at that too. But for now, let's test all the voltages at once and see what we get. Alright. It's probably a better way. I made a multimeter. Well, technically it's not a multimeter because it only measures voltages, but there's multiple voltages that it measures. So I forgot to add the ground lead. Damn it. I added the ground wire. Let's test out how it does. Okay. Accurate to 1 decimal place. I'm happy with that. Let's try it on a lower voltage. So I get another digit. Alright, less accurate now. It's fine for the 10 minutes I spent on it and the $3 I paid in parts. It is making a weird noise. Can you guys hear that? Voltages look reasonably good. I am concerned about that noise though. Okay, let's hold up a second. Now I know that some of the stuff I'm doing might look a little bit dangerous, and I probably shouldn't be doing this on a live circuit without any isolation transformer, and at a bare minimum I should probably clean up this big puddle of salt water that I'm standing in barefoot. Look, this is not a channel that will focus on safety. Now you absolutely should learn safety, but you absolutely should not learn it from me. 6 kilohertz sounds about right. That one's running at 5 kilohertz. That one's running at 7 kilohertz. I didn't think that would work. I can't remember why I'm doing this. I'm definitely getting distracted and having fun, but I need to stop and just pretend like the noise doesn't exist. Same approach I take with my car. This is something I've been working on. It's not finished, obviously, but this has a current sense op amp, which is very accurate at very low voltages, right at or even beyond either voltage rail. And I want to make this to drive a set of transistors or IGBTs and use that as an active load. But for now, we'll just test this with a passive load. I'm dropping the frequency 1 octave for the rest of these clips so it's not quite so piercing. I think I do have some idea of what's going on. This noise isn't only related to the load current, obviously. Take a look at the primary and secondary side. There's great isolation here. There's nothing going across except the opto-isolators. They don't have any electrical connection going across there. It's just an LED that shines light across. So there's no safety capacitor, which there often is. This whole secondary side is more isolated than I am in my social life. You only need a safety capacitor if you want to be safe. And if you don't really need any capacitor at all. If I touch the PSU ground, the frequency goes up. And if I touch it while I'm also touching Earth, the frequency goes down. This isn't happening just at the switching frequency. What we're getting is called subharmonic oscillation, and that's what's making this thing act like a theremin. Actually, let me try something. So why are we getting subharmonic oscillations that are turning our power supply into an instrument? Well, to understand that, we have to understand the most exciting part of life, the thing that brings together music and electronics. That's right, we get to do some math. Slope compensation, Bode plots, right half plane zeros. Okay, I've got like 5 subscribers and you'll all immediately leave if I actually talked about math here, so maybe another time. We'll just live with the noise. Besides, Ali Savara over at Bridge Digital does a great job with short videos explaining power supply math, so watch that if you're interested. I absolutely love this stuff. It just resonates with me. And if you've made it this far into the video, then hopefully you find it interesting too. Now, granted, I haven't actually accomplished anything so far other than getting severely distracted, but at this point I've just sort of accepted that I'm never actually going to accomplish anything in life, so I'm trying to focus now on the joy of learning everything there possibly is to know. And I've decided to start sharing it with all of you here on YouTube. I have no shortage of projects that I'm currently halfway through, but I'm planning to make those into videos, so if you like deep dives into repair projects without necessarily ever actually accomplishing anything, then give me a like and a subscribe. Thank you. Next time, we're going to take this daughter board off, reverse engineer the circuit, see if we can maybe quiet it down a little bit, but most importantly make the voltages variable. And also build the high power active load current sink, and also fix the boost converter that got fried after I edit this video and learn the editing software. Later, we're going to apply what we have learned here to these other power supplies that are, in fact, much more suited to the needs of General Ingvar. Hey, remember that? Before I got completely sidetracked, there actually was a point to this project.